Hi everyone, good evening. My name is Jyoti and I'm working as Senior Scrum Master in Cvent. Prior to transitioning to a Scrum Master role, I was working as an automation test engineer. And from that experience, we've created this new series in CareersTalk, which is Devops Series. Through these series, for people who are not aware about DevOps, they'll get information around somewhere around beginner to intermediate level. Now you may ask what one needs to do to become an expert. So I would say practice and lots of hands-on project. Okay, so what do I plan to cover in this series? So the topics which I'll mainly focus on this would be Linux, Git, configuration management tool. So under configuration management tool, you have Ansible, Chef, etc. So I'll be covering majorly Ansible. Then we'll talk about Docker, Jenkins. Also, I'll give you a little bit overview about AWS services and common AWS services, which helps us to leverage same functionality as that of what we have in Git. Okay. So for example, you have code commit, code deploy, code pipeline, etc. So I'll be giving you an overview of those services as well, and we'll create one project using those AWS services. Also, at the end of the series, we'll do some sample project which would involve all of these, like it would have Git, Docker, Jenkins, everything. And how do I plan to have this series? So you'll, for every topic, there would be two parts: theory followed by practical. So when I say practical, it is going to be a hands-on. Okay. And I'll be using AWS EC2 instance to do all the practical sessions, because right now I have a Windows machine and I don't have what do you say, required configuration, which would help me to install all these softwares on my machine. So I'll be using AWS. So hence, during this series, I'll be walking through AWS as well, mainly AWS console. Okay, so you'll be learning both through these series: common AWS services and then common tools which we use in DevOps. Okay, so what do we have for today? So today I'll be giving you a basic overview, like how DevOps came into picture, some common terms like continuous integration, deployment, and we'll also talk about how did DevOps come into picture, how is it related to Agile, are there any correlationship between Agile and DevOps? Okay, so prior to DevOps, we had what problem statement we had? Uh, as a developer, you had to work on new feature. Okay. Parallelly, you have to work on new product, right? So then you have your security fixes, broad bug fixes. Now there are multiple developers who are working on same piece of code. There would be merge conflict as well. So you have to resolve those merge conflicts, right? And then you have so many environments. You had your development environment, you have your production environment. So as a developer, you had to face a lot of issues in setting up these environment, right? There was a software upgrade. Okay. Also, delayed feedback on code quality, right? So since the major focus was into the development, etc., the testing, the code quality feedback used to come very late in the cycle. So this I'm talking about when we had waterfall kind of software development practices. Okay. And there was delay in time to market. Why delay in time to market? Because okay, for 1 or 2 months, all the developers, they are working on their code individually, and then we go ahead and we merge the code and we find out, oh, there is a merge conflict. We resolve those merge conflict, and since we have not automated anything, whether it's unit test cases or automation test cases, we had to run all those scenarios again manually. So all these things you takes time, right? But what people want, what customer want, they want features to be rolled out quickly, right? So you can't wait for so long, for 4 5 months to release a feature. Meanwhile, there would be a competitor who would go ahead and release that feature. Okay, so your effort would go in vain. Now comes the another side. Okay, so prior to DevOps, the developers were only responsible for your coding part. Okay, so bug fixes, new feature development, etc. Who was responsible for releases? Okay, you had your operations team. But apart from the release, they had to ensure that there is an uptime of 99.99%. Okay, so you can imagine they had to constantly monitor the production environment. Okay, and then there were multiple servers which they had to take care of. Okay, and if there was addition of new machine or new server, they had to set up all those things again manually. For that, run book used to get created, wherein developers used to mention, like, okay, for any new server, what are the prerequisite software it needs to have. For example, you need Java, you might need Git, etc. You need some other softwares as well. Okay, so imagine, see, as your customer increased, you had to increase your server to load balance the traffic. Okay, so with that, your manual effort was increasing as well. Okay, so manually you had to administrator those things. Okay, and if somebody made a human error while creating a run book, it used to get very difficult for operation team to get it corrected quickly, because again they had to collaborate with developers, and developers, they were busy in their development work. Okay, and now when we talk about production push, it used to be scheduled. Okay, so we used to have a calendar. Okay, and every team, they used to mark a calendar. And because we had limited human resource from operation teams, and they had jobs like maintaining the uptime of 99.99%, etc. They could not take care of multiple releases on the same day, so everything used to get planned. Yeah, and for any reason, okay, if there is a delay in your code development, etc., now the next schedule which you'll get would depend upon other teams schedule, right? So maybe if you were rolling out a feature, okay, and you face some issue, you have to roll back. Now you have to wait for the next slot, because there are other teams who have already scheduled the operation team's calendar for the production push. Okay, if there used to be any issue while doing that production push, again, since operation team was not collaborating with developers, both of them were working individually and in isolation, there you it used to cause a lot of problems for the operations team to resolve those issues. Okay, but when we come to the common goal, what was the common, you'll see from both the problem statement of a developer and operation, what is it that both were trying to attain, right? So they want to have a happy customers, right? So developers, they wanted to develop new feature and want to market them as quickly as they want. And similarly, operation team had to ensure that the servers are up and running. Okay, so how we can collaborate both these teams, the developers and operations, right? Or what are the ways by which they can work towards their common goal of happy customer? So they had to work together. Okay, so operations team should know what developers are doing, and developers should know what operations teams are doing, and they should know each other's pain point. Okay, um, they have to share certain responsibility. So came DevOps. So what DevOps does is it integrates developers and operation team in order to improve collaboration and productivity by automating infrastructure. So we'll talk about what do we mean by infrastructure as code, what do you mean by automating infrastructure. But in short, for example, whatever they were provisioning manually, whatever software they are installing on all the servers manually before the production push, they can what if they get those things automated? They just need to run one file, and that file would take care of all those installation. So all these can be attained through automation, right? So you have to automate workflow. Then another thing where developers can help operation team is, remember, they have to ensure uptime of 99.99%. So they have to do a lot of monitorings of these servers. So you would have heard about terms like Datadog. So what are these tools exactly? They help you in monitoring, they help you in setting up the alerts. So now you don't have to be available 24/7. You can just set up some alert. Okay, maybe alert for 500, like when server goes down, and you'll get alert on your phone or an email, and then you can quickly get online and see what issue is. Okay, so here now both of them have to work together. Developers can help operations team in creating those run books, and now they don't have to run the commands which I've mentioned in run book manually. Rather, if it's being taken care by some tools. Okay. Okay. So the mindset shift which one had to do is, now instead of working as a whole, what you can do is develop in small chunks. So you'll see even Agile or talks about what do you say? It's a iterative approach. So can you relate both here also? So in software development, we are also moving towards developing things in chunks. So you code, you integrate, you test, you deploy. If there is any error, you'll get early feedback. So even Agile talks about getting early feedback, and it also talks about customer centricity. Okay. Uh, Ensure that your development and production environment is same. Okay. Then you have to automate your code testing, right? If you find any issues, um, moment it's fixed, you should have something to test it, rather involving manual people, rather involving sorry testers to test those stuff. Okay. Yeah, again, automate infrastructure. Okay, you're automating all these software development processes, right? Okay, so you should automate even the infrastructure part, which is like provisioning your servers. Then have a source code management tool. So we'll be talking about Git, which is a source code management tool. Then you need something for performance, and then optimization. Okay, you've done all these things. Now you'll understand. Okay, how do we optimize? How do we balance the load? How do you ensure that, okay, the servers are only up when it's required? For example, uh, when there is a big billion sale, then you want a lot of servers which can manage the traffic. But when there is a quiet period, you don't want all the servers to be up and consuming the time and money of the organization. Okay. So with this change in mindset, which is instead of focusing uh, onto a what do you say whole what do you say end to end product, what you are doing is you are splitting it into chunks. And then the split includes all the things: coding, integration, testing, and deployment. Okay. And also you are ensuring that development and production environment are same. Now how can you ensure that development and production environment is same? Have a same script which is helping you to create those infrastructure, so which is like automate your infrastructure. So irrespective of development or production environment, you'll have a script which would run and which would provision these servers or environment for you. Okay. Have testing, automated testing in place. It could be your unit test cases, it could be your automation test cases. So automate. So DevOps, apart from the mindset shift, which is like coordination, collaboration, it's mainly about automating stuff. So that once you automate these things, you can focus on other important areas, which is like, okay, how do you market research? Okay. Making all these process more fast, going from on-prem to cloud. So you can do all these transition only when you have automation in place. Okay, when you have a good collaboration between developers and your operations team. Okay. Yeah. So as I said, DevOps is not just about the tool, which okay. So it's about change in mindset. So the mindset is understand your common goal as a developer and operation. Common goal is happy customer. Okay, uh, faster feedback you want. So how do you get those things, right? Faster feedback, happy customers. Your production push, or uh, how quickly you are able to fix certain things or send new feature. Okay, that would make your customer happy. Okay, so it's you have to innovate faster, you have to focus on quality, better collaboration, and now we have to move away from those planned releases, okay, or scheduled releases. So just one in month or one in 3 months. Like when I started 10 years back, we used to have this concept of mini and major releases, and we used to have those releases only on weekends, and a lot of manual step used to be involved, right? Remember, there used to be right now we have Slack, but that time we didn't had Slack. There was some other application which we were using to coordinate. Okay, so then there used to be a lot of coordination going on, and we used to, okay, we are done, then we used to call out the next person on the chat to go ahead, and until the things were pushed to production, the tester used to be available there. So for us, like, developers were done with their task, operations team were done with their task, but us used to be like, okay, test things pre-deployment, test things post-deployment, because that time also we didn't had a lot of automation. Okay, now let's understand what is the relationship between Agile and DevOps, and you will understand that DevOps is a ingrained part of Agile. Okay, so if I talk about some of the Agile manifestos value, which says individual and interaction over processes and tools. So remember, instead of giving a run book to a operations team and asking them to follow the step and do the deployment, you are focusing more on coordination, collaboration. You are ensuring that, okay, your DevOps person is part of your Scrum meetings. They know what's happening in a sprint team. What is it that they are working on? So it's more about collaboration. Working software over comprehensive documentation. Same example. Automate the deployment. Automate the testing. Automate the process to find out the code coverage or code quality, etc. Okay. Customer collaboration over contract negotiation. Yes, if there is a bug, you won't be talking to so many personals, coming to an office or sending out email to support guy, to a monitoring, to operation or NOCs, to take their approval. Rather, you have everything in place. You have all the pipeline in place. So you'll just focus on the fix, test, and deploy. Responding to changeover, following a plan. Again, you got a feedback, you rolled out certain feature, it's not working fine, or it's not what the customer was expecting, it is causing some issues. So you can, in an automatic way, you can either roll back or you can do the fix and send it quickly. Why you are able to send it quickly? Because everything has been automated. It's just a just small click and everything gets started. In fact, you'll study that you don't have to click also. So whenever a code is merged to a code repository or a source code management tool, everything starts. Okay, there is something merged to a code repository. You'll see, okay, unit test cases would be run over them. Okay, then automation test cases would be run over them, coverage would be checked. Okay, once the coverage is checked, the artifact, okay, for example, your war file, a jar file would be created, would be put onto the production server. Okay, and then again automated test cases would be run. Okay, and after that you would have created alerts and dashboard to monitor, okay, how is health of my production environment after this release. So you'll see, it's just the moment you are merging your code, everything starts. Okay, so this I'm sure everybody would have seen. So when we talk about DevOps, so this is the common image be seeing, so which is all about you code, you build, you test, you release, you deploy, operate, and monitor. And for every category you have a tool. For example, for code you'll have your Git, okay, Jira for creating those stories, etc. Okay, so you know when certain things is pushed to production, what was the corresponding Jira or feature associated with that code. Okay, then you have build, so you've got Maven. I think I missed mentioning Maven on the things which I'll be covering. So I'll talk about Maven also when we'll be creating a project, end-to-end project. So that time we'll use a Maven. Okay. Then test. So you have Selenium, you have JUnit. Okay. Now releases. So for releases, you have Jenkins and CodeShip. I have knowledge of Jenkins, so I'll be talking about Jenkins. Okay. And then deploy. Okay. Deployment. So you'll have some AWS services also, and if we talk about open source, you have Docker. Okay. And then operate, which is like, here just understand operate as like, okay, you have 10 production servers, so the artifact which you created, you want to push it to all the 10 servers, or you want to provision those 10 servers, right? So instead of doing it manually, you'll do it through uh, these tools. So I'll be talking about Ansible in detail. And then comes monitoring. So Datadog, as I told you, Splunk, so Negus. So I have knowledge of Datadog and Splunk. So I'll give you a basic overview. So though Splunk and Datadog, they're not part of this series, still I'll just give you a basic overview on what Splunk is and how in my organization we are using Splunk and Datadog. Okay. Now, three terms which you'll come across as a DevOps engineer, or a Scrum Master or a tester who are working with DevOps. So first term which you'll come across is continuous integration. Okay. So what do you mean by continuous integration is, uh, you have a source code management tool. So for example, Git. Okay, I'm also working on certain feature, even you are working on certain feature. Okay. um Earlier what used to happen is, okay, I was working on that code for quite some time, and later I go ahead and push the changes to the code repository. Okay, and it used to take time to find out, okay, who pushed the changes, or maybe since I pushed my changes first and this person pushed his changes after me, after quite some time, both our code was conflicting, or whatever he was doing, I have already taken care of in my code. Okay, so it used to get very late for us to find out root cause of the failure in case merges are happening very late. Okay, so continuous integration talks about having a common source code repository and merging your changes frequently, integrating your changes frequently. Okay. Delivery, again, so it's the ability to make changes of all types, such as new feature, configuration changes, error fixes, experiments into production in a safe and efficient manner using short work cycles. Again, in you don't have to what do you say, wait for months for your changes to go out in production, because there's already people lined up for production push. So it's like, okay, the moment you've integrated your code, which is like the moment your code is merged, test cases would start running. And if but you would have mentioned certain criterias, like for example, code coverage should be 80%. Okay, so if the changes which you have pushed, they after the push, if your automation test cases are running fine, you have good coverage, you can go ahead and plan for their delivery. Continuous deployment, again, the until continuous delivery, the push to production is controlled manually. Okay, so you decide as a engineer, okay, should I go ahead and push this to production? But in continuous deployment, even that part, pushing your changes from a development or staging environment to a production, that's automated. Okay, and as I said, since all the pieces are automated, one has to ensure that there is a good solid logging, right? That allows you to identify the increasing error count on newer version. As I was telling you, you set up alerts monitoring, but what exactly you have to set alerts on, what exactly you need to monitor apart from your CPU and memory usage, right? So you can create those dashboards, have a good logging. Okay, you are getting some errors, 500 error, null pointer exception, etc., right, after the production push. But if you don't have a logging in place, you won't be able to pinpoint the exact issue. Okay, so that's why it's advisable to have a good logging, log your errors, info, warning, except everything. Okay, and even the logs which gets created, they are saved on your server. So even it's also very important that those files are also purged, right? Because if your log files are getting saved on a server and you're not deleting them or purging them, they can also cause problems. So this is also one thing to keep in mind. Yes, have a good logging in place, but ensure periodically to purge those logs. Yeah, so this is just a diagrammatic representation of your continuous integration. So I took this from this site, which is mentioned in the slide. So as a developer, you are writing your code, then you merged your code. Okay, if there is a problem detected, you'll know it right away that the changes which you made caused this problem. Okay, but if everything is okay, you can move to the next cycle. Yeah, again, if I talk about continuous delivery, so you've done the code, your unit test cases ran, your integration test cases ran, build was done. So what exactly build does is it converts your what do you say, code which you have written to your war or jar file, and then you, on that jar file, you run your um, test. Okay, and if everything is fine, you've got good success rate, now you can decide whether you want to go ahead and deploy to production, or you want to hold on, and then you want to release once more features are merged. Okay, so when I'll talk about Git, I'll tell you about all these things. Like we'll talk about feature branch, we'll talk about integration branch, your master branch. So these things would make more sense when you come to that Git tutorial. Okay, yeah, and continuous deployment, as I mentioned, everything is auto, it's not manual. So it's same example which I was telling. The moment things are integrated, okay, you manually, you don't run your unit test cases, code coverage, etc. Everything is part of your deployment process or your pipeline, and all these things, they run on its own. Okay, yeah. So this is all what I wanted to cover in our introductory session of DevOps series. So I'll quickly give you a recap of what we studied. So we talked about what was the problem of the developer and what was the problem of the operations team, but what was their common goal. Yeah. Then we understood, okay, DevOps is not just about tools or automation. When we talk about DevOps, it's about change in the mindset, then tool plus new skill. So you'll see for everything there are multiple tools available. Example I was giving you, like you have Jenkins, you have got CodeShip. So you have to continuously learn new things, new skills. Okay. Then we learned about common terms like continuous integration, delivery, and deployment. So deployment is everything is automated. We studied about that common DevOps cycle, which had your, okay, you build, test, release, deploy, monitoring, etc. Yeah. So this is what we had in the overview. Now, what would we cover in the next session? So we'll be talking about basics, Linux command. Okay, then file system and volumes in Linux. Also, I'll be telling you about how do you start and stop the services in Linux, and all this I'll be doing it on AWS EC2 instance. So we'll be having a demo on that part as well. Okay, So for any question, guys, feel free to add your questions in comment, or you can reach out to us on LinkedIn. Yeah. And as I said, this series would give you that basic to intermediate level of knowledge. There are so many tools out there. I am sharing those tools on which I had worked when I was working as an automation test engineer. But the core principle for most of the tools are almost same. Your commands may vary, one or two terms here and there may vary. So even if you know these tools, you'll be able to learn those new tools, right? For example, you don't have Git, you have some other source code management tool. You are not having Jenkins, you are having TeamCity, but you will be able to find out. Okay, and all these, they have Linux as the operating system. That's why our first session in this series is going to be about Linux. Again, Linux is also very vast, but I'll be covering the basic commands. Okay, how do you copy a file? How do you move a file? How do you create a file? What do you mean by super user? How do you start the services? We'll be talking about file system. Okay, I'll be also talking about what do you say? What happens when a Linux machine is started? So I'll be covering all those things in next session. Okay, guys. So thank you so much, and see you in the next session soon.